Greetings, this is Charles Darwin, and I'm here to talk to you about the very interesting science of biogeography. And this is a science that didn't make sense until the beginning of evolutionary theory. Now, biogeography is just the study of what species grow where in the world. And starting with the age of European exploration in the 1600s, explorers and scientists began noticing that different species lived in different parts of the world. I'm not just talking about forests versus deserts. I'm talking about, for instance, the forests in Europe, the forests in North America had different species of trees in them. The rainforests of Southeast Asia, of Africa, and of South America had different species of trees in them, even though the physical conditions were very similar. And thus was born the science of biogeography to try to explain how this came about. Most of the early work of the modern science of biogeography was done by my friend Alfred Russel Wallace. And so to him is owed most of the credit for these discoveries. And he was in Southeast Asia, and he found, when he was on visiting various islands, that on the islands of Bali and Lombok, on one of those islands, you found the birds and mammals that were characteristic of Asia, and on the next island, only a few miles away, you found the birds and mammals that were characteristic of Australia, even though the climate of those two islands was just about the same. How did that happen? And this is today known as Wallace's line. And we now understand that what happened is the continents were moving around, the ocean plates were moving around, and that these species evolved in different places. You had species evolving in Australia, others evolving in Asia, and these plates have come together so that now the species which evolved in different places are close together. Also, with biogeography, you can find that species that were in all one species in different locations then evolved into different species in those different locations. And that's what I'm going to talk to you about regarding North America. I'm in the Black Hills of South Dakota at the appropriately named Razorback Ridge. And most of the trees that you see around right here, the dominant species, almost every tree that you see on the hills and the cliffs is the ponderosa pine. There are hundreds of millions of ponderosa pines in the Black Hills. Many of the wildflower species here are also, like the ponderosa pine, of western North American origin. You find them in the Rocky Mountains and in California and places like that. However, if you look down to Rapid Creek down below us, you'll see many deciduous tree species down there. And not right here, but in other parts of the Black Hills, there is the bur oak, which is an eastern species. This is about as far west as the bur oak gets. There's also paperbark birches, which don't get much further west than this. And there's hop hornbeams and other species of deciduous trees that grow near the water that are eastern. You will also find species of trees here in the Black Hills that grow all over North America, such as the quaking aspen and the box elder. Also, you find biogeography of birds. Perhaps you've noticed some birds flying around here. These are violet-green swallows, which are characteristic western species of birds. But also in the Black Hills, you will find eastern species of birds. And so what you find is the Black Hills, which is it's isolated out in the plains, about 100 miles west of the Rocky Mountains. It is the meeting of east and west, a biogeographic workshop, so to speak, of evolution that you can see here in the Black Hills. You don't have to travel all over the world to see biogeography. You can see it by just coming right here to the Black Hills. Also in the Black Hills, you can find remnant species that used to be more widespread right after the last ice age, but today they're found only in tiny populations, nearly extinct. For instance, the limber pine. I know I've done a video previously about the limber pine in Texas. There's also some here in the Black Hills, very small population left over from the ice age, even though you cannot see it right here in this video. Now, how did the different species come about in North America? Well, about 70 million years ago, the North Atlantic Ocean was very narrow, and so Europe and North America were connected, and also the Rocky Mountains and Sierra Nevada Mountains had not yet risen, so pretty much you had one plane of evolution. However, since that time, the Northern Atlantic Ocean has widened, the Rocky Mountains and the Sierra Nevada Mountains rose, and so that separated this arena of evolution into at least three. You had the European species evolving, Eastern North American species evolving, and California species evolving. And so you have different species of oaks in all three places. 70 million years ago, they might have all been the same species, but today you have characteristic species for each region. Well, this is the sort of thing that you can see if you come to the Black Hills and to other places that are a meeting of East and West, a place to study biogeography. And that's also a science that makes sense primarily if you understand the process of evolution, how different species evolved in different places, and then, in the case of the Black Hills,